Let's go to the test. Let's go to the 30 past paper. Nearly finished this one, right? We're almost finished. We have done a Bohr model last time, Bohr model. And also we work out the area. This one. We don't have, right. Oh, that is a conservation law. Did you solve this problem?
No.
No, so explosion. So basically you have the equation to build the conservation law. I remember. Do you want to continue or go to next question?
Isn't it already like very close?
Yeah, we built the equation.
Yeah,
we built the equation.
We got a simultaneous equation.
And how about the B? Higher speed pieces can be obtained if direction of movement of pieces are different from those in part A. Higher speed. Under which choice of the direction would the maximum speed of one of the pieces be achieved? So this is a related question. Do you want to go to B? We have done A.
Yeah.
So basically, this question continues. They have one object. All of a sudden, explosion. After explosion, it became 4 pieces, right? So initially, they got the velocity upward. We know. And after that, we got 4 pieces, and go all different direction. Did they say the direction is the same or
different?
Different
from A. Yeah.
Yeah. So that we have, so we follow their notation, which is 1 explosion. M3, M4. The piece is 4 moved vertically. This is 4, this is V4, right? And the piece mass 1 move vertically. So M1. So V1, M1 doesn't matter. M3 and 2 move horizontally. Obviously, they have to go to different direction, right? V2, V4, V3. So we have done that by using conservation law, right? That is a before, is a before and after. It's before collision and after collision. So when you encounter this question, you have to think whether we can apply conservation law, because air friction is emitted, so therefore we can use both energy and momentum conservation. Now, let's consider what higher speed can be obtained if the direction of movement of pieces are different from those in part 1. Different. Under which choice direction would the maximum speed of one of the pieces be achieved? Under which choice of direction? Well, that's a bit tricky, the question. See, they have to recall what is the direction. Do we know the direction? Higher speed can be obtained if direction of movement of the pieces are different from those in part A. So how can we achieve the velocity? By changing direction. Oh, so, well, in that case, I suggest they just go to a vertical. Do you agree?
Yes, because gravity. I was thinking about that.
Yes, good.
Yeah, and because M1
because important thing is the total momentum is fixed. Can you see?
Yeah.
Total momentum is also this total momentum, which also the vector, right? Is upward. Is upward.
So if you achieve maximum velocity, the mass should be the lowest. I was thinking about M1.
Yes, they have different masses, right? The masses are different. And how can we make this? Do they say one of them or just make one of them?
Just one of them, yeah.
Yes.
So it's M1.
One of the pieces achieved. Well, it's not straightforward, this question solution. So basically you have to So originally it's move upward, right? Move upward. If you achieve this, or you can minimize the velocity. Can you see? Because you got momentum equal to n multiply velocity, right? To maximize velocity, then you have to minimize the mass. Do you agree? Can we change the mass or only change? Oh, probably not, because we can only change the velocity, right? Change the movement direction. So we cannot change it. So mass is not variable. So forget about this dependence. But if so, we can make it smaller pieces, right? Smaller pieces move faster. That's according to momentum conservation. But no, this is not the right way to go. One of the pieces, so they just speed one of pieces be achieved. Under which choice of direction? So you can change their direction, okay? And how many choice? What is the freedom for us to change the direction? Can we change them to go to one direction? How do we change the direction? Because horizontally, they just consider momentum conservation, all right? And if you swap the 2 and 3, there's no much choice, because horizontal, the momentum is the same. And oh, by the way, what is this? Can you follow this order? This is 1, this is 4, this is 2, this is 3. All right. Which mass? Can you list the mass? What are the mass? M1, M2, M. You tell me what is the mass is 1, right?
Yeah, 1, 2, 3, 4.
Oh, really? Yeah. Oh, that's interesting. So mass, the heaviest is mass 4, right? 1, 2, 3, 4. In which 2 and 3 are different, and mass 4 are heaviest. Oh, can we just swap? 1 and 4? What do you think? Because if you move, can we swap these two to see, can we make a difference? We can't do much about 2 and 3 because it's horizontal, right? Its initial momentum is always 0. So they cannot achieve, it's impossible to change the, if you just swap 1 and 4, that can make a difference. Do you agree? Why? Because we can still we still can use this idea. Can you see? Because if you think about it, so if, for example, if we have the if this is our solution, for example, if the, because you see, I tell you what, this is originally without before change. So the 4 minus 1 must equal to m, we know. Do you agree? This is conservation law.
Yeah.
Okay. Now, if we just rewrite this one, so this is before we swap. So this is 4 v4, right? Minus m1 v1 must equal to, that is after. Okay. This is initial. You can see right hand side is initial. Do you agree? So in this case, m4 is 4 times, okay? Is a 4 times of the velocity of the mass 2. Can you see? Mass 1, all right? So we just swap that. That become m1. M1 is smaller. Can you see?
4 m1.
There's a v4. I just swap them. They can change the direction, right? I just swap these two. That's the same. Can you see? This is the same constant. Now, can that make difference in this case? Can we say these two velocity will change? Because the I tell you what, the two components will be the same. Can you see? These two will be the same because we are talking about momentum. Do you agree? So I think that's one way to go, because if you you see one before you swap is it's 4 multiply V4, okay? And these two must be the same, or are they? Another is 1 V1, right? I'm talking about the two momentum. Can you see? I'm talking about the two momentum.
Yeah.
And their difference must be constant. So one is larger than another. Can you see? So basically, can we just draw this diagram? So if this is if this height is P4 and this height is P1, all right? And the difference will be initial. Can you see?
Yeah.
M V null. So what now we because in other words, P4 is always larger than, significantly larger than P1, all right? And now we shift. So P4, can we just change that's before and after? After we change, oh, be careful. So after change, the velocity, oh, it's tricky. The difference is the same, is constant, but not necessarily they are the same, all right? It's not straightforward. We have worked out the velocity, right? Velocity, what is velocity? And oh, it's very tricky. It's not straightforward, I think. What do you think? Because in this case, we have to consider the before and after swap, right? And the P4, if you divide, reduce the mass, you know what I mean? This, can we just write the mass first? That's before. That is V4, okay? And swap to just one V4. But of course, the V4 will change, right? I use the dash means V4 is changed, all right? Originally, this P1, this P1. P1 is 1 V1, and after swap, that became 4 V1 dash. So relatively speaking, if that difference is kept constant, does that affect the velocity of this? So do you think this will change? This piece, let's just find another area. What do you think? Just read it. Higher speed pieces can be obtained if the direction of movement change. Okay, we just follow this idea. All right, there's not many choice, except exchange swap the 1 and the 4. All right. So we have to set up equation. Can you see? In other words, the difference. Can we just say can we just make an argument before the change? The difference between these two V4 and minus V1, it's just 1 multiply 1, mass is 1, okay? Is equal to a constant, right? We don't have to use no, just n, the total mass. After swap, we got 1 V4 and 4 V1. That's after the change, okay? But the difference is still the same, all right? Now, there are two equations. Can we compare?
But you got four unknowns.
Sorry, this
velocity. They are unknown.
Because we just swap the mass, isn't it?
Yeah, but I think
this is conservation of.
Would you need the velocity calculator from the last question? I think.
No, it's not important because we need to, because we at the moment we just consider the conservation of the momentum. Can you see? So this diagram tells us the difference between these two are the same.
Yeah.
Now, can we just try to, can we solve this problem? Can we just compare these two? So basically they are the constant, right? And they are there are only two unknown, right? These two velocity is given or can be calculated, yeah. So yes, we have to understand. So these two velocities given, okay. 4 and 1 are given, okay. If 4 and I can we just categorically we just assume it's not a big deal. We just think that we just consider velocity A, the difference between the two. We have to somehow to simplify this. Can you see? Can we just rewrite this as how can we compare? So what we are looking for? We are looking for the change, right? If you put them together, can we solve this first? So 4 with 4, can we see? So 4, can we just minus each other, minus, we will see. With 4 minus, with 4 dash, and we just and these will become minus, that would be, we just minus, V1 takes 4, V1 dash, and equal to 0, okay? We just see how far can we go. Does that guarantee that
you got two unknowns?
Because it's 4, you see, this we just minus each other. Can you see? We minus this equation.
Yeah, but you still have two unknowns in that equation, and you only got one.
That's right. No. We don't know. We probably from previous question we have solved this too, right?
Yeah, but still two, the dash, the prime.
Oh yeah, that's right. We only had one equation. Yes, probably we will focus on the second equation. Do you agree? This second equation matter, right?
And it feels so counterintuitive because
no, this is obvious. Well, just my without go to detail, without quantitative, I say the velocity v dash will increase, right? But there is no guarantee because we only know the difference between the two at constant, which couldn't like this, okay? Maybe which after swap the situation will be looks like this. Can you see that?
Yeah.
What do you think?
I was thinking that isn't gravity like effective to those pieces?
Or it's too complicated. If you just consider the after explosion, you have to consider you have to wait for a while. The situation can be complicated because each object will continue, you know, to do the up through motion. Can you see? And you have to consider if you want to take gravitation into account, it's more complicated. We just focus on the instantaneous after the explosion. That's the simplest scenario. Because if you want to waiting for a while after explosion, and these 4 objects will move in different direction, can you see? We're not interested in that that far. Okay. Now, can we just focus on this idea? If I just change the mass, I just return to the first idea. If the mass is increased and the F4 must be increased, can you see?
Yeah.
Okay. And how about, so let's just consider this scenario, but we still have chance, okay? So basically we just make this argument without solve this equation. What I can do again, so what I trying to work out, I can draw the better diagram here. So we know the velocity 4 will change after swapping, right? So for example, this is velocity 4, and velocity 4 after that will change a lot, right? One moment. This is velocity 4, and if the product is constant, okay? So if you change the 4 will increase a lot, right? Can you follow me? Because not 4 times actually, 4 times, right? I still use this idea. Do you agree? This is the mass. This is the velocity. Can you see the product is the same? You see? So the product, so the mass and the velocity equal to the constant. Can you see? That's velocity, right?
Yeah.
So therefore, velocity must equal to c divided by m. So the reciprocal, right? In other words, if I just, I think this is the way to go. I feel that way. So if you this is a v4 at the beginning, right? And after that, you actually increase 4 times. So this is just this v4. Can you just stick with this method, right? That's a v4 dash. Okay. Now what happened to the v1? And v1 is it's another is decrease, right? But we know that difference must be kept the same. So this momentum, can you see that is initial momentum? Can you see momentum 4? This is the momentum 4 dash. And this difference must be a constant, okay? So what happened to the V, can we see this is slightly different in that case, this P1 must be smaller than P4, do you agree? I can use different color. P1 must be smaller than P4 because their difference is positive, can you see? So this is P4 before swapping. P4 take P1, can you see? So P1 is smaller, can you see? That is, so this is P1. And that's V1, okay? That's this height as a whole is P1, right? P1. Oh, there's no guarantee. Oh, hang on. I have to decide how to use velocity. I'm talking about the velocity label, not the momentum. Oh, first question is, okay, let's just return to the velocity. Velocity will certainly decrease, right? Velocity will certainly decrease. Wow, how can we do? How can we solve this trouble? Is this possible? We want, because when the mass increase, velocity will decrease. Do you agree?
Yeah.
And oh well, that is what we want. Can you see? That's probably answered the question already. Can you see that is a fact? The velocity increase when you change the when you swap the mass. I think that is a simple question. It's more we not as complicated as that, like as we thought. Can you see? I think we will stick with this diagram. All right, we will stick with this diagram that the mass and the velocity is reciprocal. If the mass is reduced, velocity is increased. Well, I think the original question is that just change the direction, all right? So I think we're just to summarize. So basically,
So you mean that M4 in part A has more momentum than has given more momentum than M1.
Let's just put that. I think that the original question I remember is ask the change the direction. This is the original one. So what I do, I probably just change that into this is mass 1. I put the mass 1 up or put the mass 4 downward. That is after we change it. We in this way we change the direction. You see, we change the direction of these two pieces.
How do you know that P4 is originally larger than P1?
Oh, because this is because initially the momentum is upward. Can you see? Can you see that? Can you put it? We know that's the initial momentum. Can you see?
Oh, that's what I got it. I got
it. This P must be this P, now this P1 must be larger than. Can you see? Or the difference between these two must be always positive. Can you see? If you swap them, that's momentum conservation. I think we don't want to spend too much time. We stick with this diagram, okay? If we have new idea after a few days, we can come back to this question. All right. Do you agree? Let's go to.
Yeah, I think I can get it after
Yeah.
a window P4 is larger than P1.
Yeah.
So that you swap the mass and increase the velocity.
That's right. That's that. I think I will stick with this idea, and it seems okay. Save this piece, and go to next question then. Yes, it's a sales question. This is interference, right? Look like interference. Can you see the question? I found some space here. Is that too small, the word?
I can see.
Okay, good. Just look. Okay. The diagram below shows the interferometer. So it's just interference phenomena with two paths, A and B, which a wave can take from paths which a wave can take from its source S to detect B. So these are all they got the source and two different paths, all right?
Yeah.
So they want to compare after these two beam meet again. So they call the splitter here, right? They join them together after travel different paths. Okay, that makes sense. The paths of the lengths of paths differ by amount of L. That is, there is a path difference, which can change with time. Okay, the intensity of detector I is measured and vary as a function of this one. So that is air become dependent, right? P and Q. In the above, K is wave numbers. Yeah, you know wave number. Wave number is just reciprocal of wavelength. Wave number, can you see? So it just sorry.
The number of waves.
Not reciprocal. I just write down here. How? We just share. Where are we? All of a sudden, I couldn't find my. Did I close that window?
It's up there.
Sorry?
It was up there.
No, I probably closed that window, I think.
No, I can see it.
You can see it? Yeah?
Yeah.
Where is that?
Hey, open that window again.
Yeah?
Not this one, the previous one.
It's been a nuisance. I opened again. I couldn't find it.
Yeah.
It's been a nuisance. That's never happened. I probably clicked the wrong button. Okay, try again. Yeah, it is interference. So the two beams join together with different path difference. And obviously they will give the pattern black and bright and dark. So you will determine to the formula is given. Formula is given, okay. Okay, let's do it. Prepare some dark background. Oops. Okay, do you want to try? And this is just based on the path difference. Okay. What is I? I is intensity. The intensity, right? Do you know intensity? Intensity is I write intensity here. So intensity. When we found the intensity is proportional to the square Do you remember intensity formula here is proportional to the amplitude square. That's called intensity. They tell you what is K. So in this case, they write the question here. So I equal to the sum of IP. IP is constant, right? IP is constant. IQ is constant. This just represent this formula. So the cosine, they got the K number. K is called the wave number. Okay. So K is wave number. Yeah, we just write the original form. Can you see the? That's easier to follow. So basically, we got to the L. L is variable. Can you see?
Yeah.
L, capital L is variable. So that is the intensity formula. Now, sketch the intensity. So you have to draw this diagram as a function of L in the range from 0 to 2 lambda. Okay. So can you draw that? So basically, this is just if you know how to draw the cosine function, you should be able to draw that. You agree?
Yeah, right.
This if you know how to draw this one, we can build that afterwards. All right. So can we just do cosine first, right? Otherwise, we'll have to put this displacement, say the shift. I just draw cosine first. Can you see? So what cosine is simple to. What is cosine? You tell me. It's very simple for cosine. Can you see? We basically ask you to, in let's just write down here. So the y, so y-axis here, I just draw cosine. Okay, cosine. That's right. That is L. That is a 1. This is 1. You have to do 2. You have to do 2. Can you see? I do another one.
Okay.
Yes, we can just a sketch. We just do sketch. Can we draw that for you? Can we draw that from my side? I can control that easily.
Okay.
Can you okay, I deleted 1, 2, 3, 4. 1, 2, 3, 4. So for cosine, this is 1, this is -1, right? So you set color, so that cosine like this. And that is 1, another one. That's it. So the rest just it's easy, right? You just added them by p. You just added them by p and shifted them by p. For example, you put them upward by p. So we don't have to do that. All right, it's very simple. We just if you just want to draw another graph. Yeah, if this is our new axis, yes. This is our L, and this will be IP. Can you see? There'll be 0. There'll be IP. Okay. So that will be this will be IP plus IQ and IP minus IQ. Okay. Yeah, it's very simple, this question. Sketch that, we have done that. And we wish to use to measure the path length difference, L, by measuring the intensity of detector as a function of time, okay? The change in path length difference is delta L. Okay, indicate on your sketch the biggest delta L you can infer unambiguously from the measurement of intensity. So what the obvious intensity will change according to this formula, right? So I just put the 0 here. This is our new origin. This is our new origin. So this is a lambda. Sorry, this is one wavelength. Yes, that's one. This is 2 wavelengths, right? It's 2 wavelengths. So that is a diagram. And now label both the second one. Changes path length. We wish to use infer to measure how path wavelength difference. So by definition, L is path difference, right?
Yeah.
the length path it differ by the amount. The path, this is path difference. All right, that makes sense. That's but what is the delta L?
Change in path difference.
Passing this is a it's a difference, right?
Yeah,
And pass that's very strange idea. So pass A, take pass B equal to L, equal to L. Does that mean that, right?
Yeah, you just give a range in the sketch.
Ah.
Yeah. Or a domain. A domain.
Or domain or just 0 from 2 pi, right? Is that simple as that? They ask you to do this in the A, question A, from 0 to 2A, right? We have done that.
Yeah.
We have drawn the A. I'm not quite sure what the question will be. Indicate on your sketch the biggest delta L you can infer unambiguously for the measurement of intensity. The biggest, what do you mean? So the change in L must be confined to a certain number, right? The change in the length part is we wish to use in interferometer to measure how the path length difference with the time. Aha, time is changing. Time by measuring intensity. So there's a new variable time here. Can you see?
Yeah.
So in other words, oh, I see. So this difference is time dependent, right?
Yeah.
This difference time dependent. Do you agree? So this time, this difference not constant, isn't it?
So you have to draw another graph, which is L against T.
No, we just probably use the idea of the calculus. So can we find the because they are talking about delta V is a differentiation, right? How can we introduce this variable? So, oh, I see. Can we just consider this is the variable L? Can you see? L is a function of time. So we can do first derivative, can we? Because we can find we can in this way can write down here. We should be able to write the delta. So we are looking for delta L. Can you see? By in calculus, what is delta L? Delta L is equal to first derivative, right? dl dt multiplied delta t. That is, have you seen this calculus here? So if x, y, if this function is changing, right? How do we work out delta L? We just use this first derivative. If we know x, if we know delta x, can you see? This we use x and y in this diagram. So this is delta y, delta x, can you see? So if we know the first derivative, we should be able to work out the delta L. Is that right? So we have to assume L is time dependent by measuring the detector as a function of time. Raw. Okay, so can we just find the first derivative in our case? That is the di dt. Can you see? First derivative. Find the first derivative first. Di dt will equal to the cosine is negative, right? Become sine. K is constant. L, I will have put Q here. IQ. And multiply, and there is a dl dt. That's first derivative of this change intensity, right?
Mm-hmm.
And there's a constraint of the delta L when we as approximation, can we say delta I? You just multiply delta t. Can we follow me? We just use this simple idea. We have put a k here. A little bit of calculus. Can we put a k here? KIQ multiply sine KL, all of them multiply delta L. You agree? So if in other words, this is this is time dependent. So the large is L, the large is L. We are looking for biggest delta L. You infer. That's interesting. So this thing, can we just rewrite this formula in terms of L? L will equal to negative, right? And 1 over KIQ sine KL. K is constant. This is delta I. You see? So they believe that delta L have the kind of the maximum, right? Do you agree?
Yeah.
What is the biggest L? That as a function of delta I. This question is unclear. L is time dependent. So we found the first derivative. We found this dependent on change in intensity. So okay, we can argue that intensity change is between this range. Can you see? This is the maximum intensity can change. Do you agree?
Yeah.
So maximum intensity change is just 2 IQ, isn't it? So can we just write down here? So the maximum intensity change, because intensity is from the so this is dim, not dark. This is dim. This is bright. This is brightest. Can you see? Yeah. This is brightest. This is dim. It's not necessarily dark. Okay, but the difference is between these two, right? And if the change is that is the maximum, so that in terms of this experiment method, that give us the maximum. So that maximum, this maximum number is determined by that 2Q, 2IQ, you see?
Yeah.
Okay, if we substitute this number, what can we obtain? So that makes sense. Can you see? If that is the case, because that's the argument, so therefore, so delta L will equal to, if we substitute that into this formula, will became this cancel. That became can we put lambda here? 2 lambda here, divided by k, divided by 2 pi. Can you see? And that's called they got sine k, sine KL. All right. So this must have maximum. Do you agree? Oh, it's 0. Oh. Can that equal to 0? I thought this will depend on the path difference. It's a reciprocal function. When L achieved maximum, and this sign must be go to maximum. No. Well, that is strange. They are looking for biggest delta L, right? It's the biggest delta L, we can't achieve that, because if you let sine function equal to 0, that will be undefined. Can you see? That's a tricky question. Can you follow me? I'm trying to use this argument that the intensity the range, can you see? That is the range of intensity change. So if we use the maximum, so basically the maximum intensity used, then we can determine that the largest delta L. However, this constant, so this one is dependent on the L. Oh, probably we just use the formula. Do you have to calculate that? Yeah. Oh, we just found the formula. Okay. Oh, we just use the formula. Can you see? Can you write down here? This is our result, all right? So we don't have to this is just a formula because we don't have to change this factor sign. We just use this idea. That's probably, I think that is do you know what I mean? Because since there's a delta L, we based on this argument is proportional to delta I. Can you see? We will forget this one. I tell you, we can discuss. We just for this is just factor, isn't it? It just is proportionality, right?
Yeah.
And when L change, of course, when L change, that will affect this L value because that depends on L. But if you just consider delta L, not L, so in this case, I'm pretty sure that is how we go. Can you see? So because also delta the maximum, so that's why. So it's proportional. Can you see?
Is it inversely proportional to L?
No. It's proportional. Can you see? Can you see this formula here? We derived here.
Yeah. I mean the changing L to L.
Well, in this case, we can just say when this is proportional. Can you see? It's proportional. So once we choose maximum here, then we should work out the maximum formula for this one. So that is why delta L. Can you see? So that is the formula we derived. Can you see this formula?
Yeah, but it asks you to sketch on the graph.
Indicate your sketch. Yeah, that's another question.
I was thinking that you need to find a relationship between changing L to L. Do you?
Well, the L change, well, the diagram, if you use the graphical method, that's another issue. For example, if the L change, so this is when L getting smaller, that will, can we say that will change like this? Can you see? That is due to L change. R increase. When L increase. Yes, I think if that's how to change that one. Can you see? Can you see that orange color?
What is that? Is it changing L?
Can you see my drawing here?
Yeah, I can see the orange one. What does it mean?
So that is when L change a little bit. Can you see? This just like function. So so for example, this is this is a cosine x, right? And this is just a cosine x plus something plus a.
Yeah.
It just is too bright. Okay, just use some dark background.
So you would say that changing L is inversely proportional to L?
No. I answered this question already by this algebra, right? Well, we'll just see how can we illustrate by this diagram. So basically, if you if you want to use this diagram, I don't have to draw it again, but let's do it. So if we just focus on the cosine diagram, right? We just focus cosine diagram. So where is this 1, 2, 3, 4? I just draw one. We just draw just one period. So let's just use this this diagram. This is so this is L. So these are the function of L. Can you see? So this is a cosine, a constant multiply L. L is a variable, right? So if L is changed, so what would happen if L is small? So how can we change? So when L is changed as a function of time, how can we draw that?
It affects the period.
Because in this case, L is function of time, right? And can we just assume the function is constant? Can you see? Yeah, that is, t is different variable, right? You have to know this function. We don't know, unfortunately, we don't know this function, right? We know it's time dependent, but we don't know what this function is.
I'm so confused.
Yeah, very confused, I think.
I lost it during this section.
Yeah, well, well, let's discuss in the future, all right? Because I really, sometimes, as I said, if you don't follow their past exam, you don't know their mind. You don't the examiner what they want to ask, you see. The idea is that this apparatus is an experiment. You can consider this as experimental setup, which allowed you to work out the variation of this parseness. Okay, the parseness is time is time dependent, and also, oh, if that change, if this cosine change, I think basically they probably, apart from shift, they probably change like this. Can you see? That process, no, this not. This will affect the amplitude. Okay. We stop here, right? There's no point to continue. All right.
Okay, I'm in pain.
Correct.
I'm in pain.
No, don't worry. I think you see we have solved at least 80% of these questions. All right.
Yeah.
And
I just couldn't follow this part. I don't get it. This one.
No, I tell you the background. Okay. I think we have found a way out. We in this case, can we just go back? So let's go to whiteboard. All right, go to whiteboard. So it's I tell you some background. Okay, that will give you some confidence from the whiteboard. I think that's why if you happen to familiar with this related topics, then you found that solution is easy. Okay. But the background is very simple. I give you the background. So they got a source, can you see? They got the same source and they split into two, all right? As a result, the path length will varies, okay? So this path length called the path length called path A, and that can, they didn't tell you how, but certainly you can change the path length of these two, right? So they got a detector here. So that is experimental setup. This is called split, okay? We know that without their formula, we just added them. If we just assume this is, can we call this time dependent, you see? So path A is y, can we call the y? Y equal to, I can just use FG, just make sure when we can denote this phenomenon. So this is time dependent signal, okay? So this is this YA, is YB, okay? YA, YB is a signal, okay? S for signal, time dependent signal. So basically the time signal, I tell you what, is called time series. So if you monitor the intensity, you see that is a signal, that is a function of time. So this is time, all right? So this signal, if this is perfect sine function, then we should get to we can add them up. Can you see? So that's signal, right? And however, the signal at this stage, the signal is the same, all right? But after that, the make the path difference. So the phase is changed, okay? The phase is changed. So what we can say is that after the meet, well, before that, we have to write this function first, okay? So I use S, I use B, doesn't matter. I use SA, SB. So the S for signal. So SA is a function of time. We just and there must be sine function, right? We can use amplitude 1. In this case, in order to cause interference, they must be, the amplitude must be the same. You see, can we just consider sine function? So this sine function, this they travel from this path length, so that the as function of time, and we can have write this function. So it's time minus this wave. This is just like wave function. This is called 2 pi divided by L. Can you see? And another signal, B, can be written as, because the frequency and amplitude must be the same. The only difference is their path length. Can you see? Omega t is time depend. I put this time. I put the time oscillation term here. That will be, and also the wavelength must be the same. Okay. So the path length is different. This x1 is x2. So what is the path length? Path length is difference between x1 and x2. It's called the path length. Can you see?
Yeah.
So this is the mathematical form of these two signals. Now, if you add them up, can you see? So after that, so this became the sum. Can you see? Can you call this is the sum? This is a total signal. So this is the initial signal. It's total signal. The total signal will equal to is also the function of time. Okay, that will equal to the sum of these two. That is, in this case, it's if you add them up, it should be product. I think it should be product this time. They are not simply add them up. It should be, let's just consider it product. They put the two signals together. Okay, if you write this formula down here, that will just equal to a squared, right? And you call this alpha, they call this beta, just to sine function variable, right? That will become sine alpha multiply sine beta, right? Now I have to think whether this, well, this one possibility, which is a signal product, all right? Another possibility, the in this setup is just simply the sum of these two, right? They put A outside, which we can consider two possibilities. Then that would be sine alpha plus sine beta. Can you check your trigonometry formula? Can you find the sum of the two? Can you rewrite this sum of two in order to get the product? There is a trigonometry function to convert this A. I check that for you.
There's no such equations.
One moment, the trigonometry function.
I have it here, but there's no.
No, I write down here. This is I write this formula for you. Yes, sine alpha plus cosine sine beta. Sine beta. So these are simple formula. Can you see that equal to 2 sine alpha plus beta r divided by 2 half angle. Have you seen this formula? Cosine alpha take beta. Can you see this angle, this formula in trigonometry?
No, it's not on there.
Wow, this is another issue. Okay, we just use this formula. We need to obtain the formula we want. All right. So this formula is correct. Okay. If you just add them up, what can you obtain? You tell me. Can you use this formula? So alpha represent this variable, this term. This is called alpha. And the only difference is one is x, one x2. In this way, we can incorporate this L into our formula and see the time-dependent part. Can you see? One is sine. Do you want me to try? One is sine with alpha plus. That became 2 frequency t, right?
Mm.
Do you agree?
Yeah.
If there's a sum, that's a 2, and divided by 2, or divided by 2, yes. And how about cosine? We have cosine theta. We're trying to find the difference, x1 minus x2. That is path difference.
Right. Oh, I didn't write x.
Yeah, these two x are different. This is the sum of these two, right? So can we get just your k here? Is x1 plus x2. Do you agree?
Yeah.
Okay. The second formula is, so omega disappeared. Can you see? Omega disappeared. That's right. That's what I'm looking for. We got this factor. Oh, that is exactly they give you. Okay. That was the path length now. Can you see? So in other words, I'm sure now. So the phenomena in this question is work out this this is time. They got time dependent part. Can you see? This is time dependent part. Can you follow me? This is time dependent part.
Yeah.
They got the t here. Oh, as well as L. So L is also time dependent. But if we measure this as a function of L, then we will have to treat the first part as time dependent. All right. So again, we'll continue next time. All right. I think this is the background is put the two signal together, and so that when the path difference change, and the intensity will change according to the diagram you just drew. Okay. So if you have time, why don't you go to the trigonometry to see if we were going to use this formula to solve this problem? Can you understand?
Yeah. Like I still have questions about what you did in the previous page, so now it's like more confused.
Well, I think that is, I'm not surprising because this is this is back. This page tell you the background. This if you study in electronics, if you want to design the circuit of this in electronic devices, and that is called a signal theory, electronic signal theory, and in which this interference is between the two signals, which are time dependent. So the intensity can be measured, can be displayed by the by the screen on your screen.
I can understand the concept, so I just couldn't get the mathematical part.
That's right. So you have to think this is originally this signal is just the same, and this is called a splitter. Okay, you have to. It doesn't matter. If you haven't studied this one, how can you? So this is called a split or divider. At this point, one signal is divided into two parts. After these two signals are identical in their amplitude. Can you see? Their amplitudes are the same. The frequency is the same. However, the path difference may be adjusted. As a result, when they put the two signals again, we will see this intensity measure. This is called a detector. Do you know what is detector? How do we detect a signal? So if you happen to say electronic, what? So the signal is if you want to know what is detect is, you have to know what is how do we measure that electrical signal in the first place? For example, how to no you know that ammeter, you use ammeter or voltage meter, right? But this ammeter and voltage meter is not measuring the constant voltage. The signal is change, so it's time dependent. in order to find this time dependent, you have to find this formula we derived here in the first place.
Okay.
Can you see the two signal here? If you think you can solve every problem that which is at this stage, which is unrealistic, I tell you. So you first have to know what is the signal first. Can you see? You know the signal, then you know it's time dependent. Then we can use this formula to dealing with the time dependent part. In high school, we don't start. That happened in UK. That probably in the UK, in the senior school, they will study some high level electronic. Have you studied transistor, amplifier? You don't. Yeah. No. In old days, they study a little bit, but all right. I warn you before, and there are some questions. You know, it's not just difficult, but also unheard. You see.
Yeah.
This is just one of them. This is just one of them.
Can I ask you this next time? I really don't get it.
But you have to make sure you have to prepare some trigonometry base. We are using trigonometry to answer this question. The time I told you a time dependent part is here, all right? But if you can use this trigonometry, then there's no point to go further, all right? It's interference. Basically, it's interference. Can you see that amplitude is dependent on the L? Can you see that? The amplitude is dependent on the L. The cosine function.
Yeah.
Doesn't matter. We know this would happen, okay? And what we could do, if we had encountered this type of question, we would just study the related topics, okay?
Okay.
There's no guarantee Australia curriculum allows you to solve every question from UK, right? But you see, we will make some progress, all right? Up to you. If you think this is too challenging, we probably will just go back to solve other questions, all right?
Yeah.
So what is your objective? You want to solve every question you see for the first time?
I just got too confused. I just need more explanation on this.
No, explanation is if you have studied that one, you can recall your knowledge, all right? But the question about the signal, you have really to sit down to see how to describe a signal. This question is about a time-dependent signal. All right. So there's no. Be realistic. If you think you can understand everything, this question about this is unreal.
No, I mean the mathematical thing. This one, I circled it out.
Mathematics, I can tell you. If you just stop, after this, can you just go to watch to try to find this formula? Otherwise, I show you next time. All right, how to solve this, how to use this formula. I show you next time.
Yeah, I think I learned that one in class. It's just not on the sheet.
Yes. No, take easy. I think where's my?
Can you see the equation I circled in blue?
One moment. Where's my mouse? Find my mouse. Sorry, what's your question?
The equation I circled in blue is in the previous page. I didn't understand.
Oh, let's talk about next time. Okay.
Okay. Yeah.
Yes, the time is over. We'll have to be a bit tired.
Okay.
Can save that. Save that. Yeah, I will send that to you. Please digest the mathematical part. Okay, we'll talk about physics next time. Okay.
Yeah.
Okay. Goodbye.
Thank you.